I'm here to just talk about a newer project that we started this fall, where we're developing species distribution models for cetaceans with slow-moving passive acoustic data. I really want to emphasize this as a nice collaboration with my co-conspirators, rather, Celine Fergosi, Janelle Badger, and Devin Johnson. So some background information about PAM programs, or passive acoustic monitoring programs, at the NOAA Fisheries. 7 programs are supported, 1 at each of the 6 science centers around the nation, including 1 from the Office of Science and Technology, the Ocean Acoustics Program. Each program collects various types of underwater recordings depending on their research priorities. As you can see on the graphic, there's some examples of different types of hydrophones within different PAM systems, collecting different kinds of data, anything from marine mammals, which is my interest, fish, human sounds, and even just the overall marine soundscape. We use these PAM data to understand changes in species distribution, their behavior, and sometimes density. The project today that I'll be describing and sharing about is part of this overall PAM strategic initiative. This is a newer, I guess, collaborative effort funded by the Inflation Reduction Act. This effort will be involving all 7 PAM programs across the nation, and they're really divided into these 2 themes: the national data analysis integration, and then developing infrastructure and efficiency, all related to progressing PAM data and making this transformational progress towards a national PAM enterprise so that we can provide these data into stock assessments, looking at long-term trends in species, as well as climate impacts on the marine ecosystem. So for this particular project I'm working on with my collaborators is that, we're developing this framework to incorporate this slow-moving recording platforms into cetacean species distribution models. And this is really motivated by the need to basically get baseline data for a lot of the cetacean populations around the nation in each region. It's meant to improve the precision of our information for stock assessments about cetaceans. It's helping us, intended to help us improve our seasonality and also the geographic scope, where we don't necessarily have to rely on large ships to do our research. So with slow-moving platforms, what I mean by that are usually underwater gliders and drifting buoy recorders. So on the top, this is just an example of one type of underwater glider modified to have a PAM system along with the normal oceanographic sensors. Underwater gliders are piloted remotely by someone on land. They're buoyancy driven. They require low power, and they can dive down to 1,000 meters over a course of about 4 to 6 hours. So someone is babysitting a glider pretty much when they're out deployed out at sea. And then the glider comes to the surface, transfers data back to the computer via satellite. On the other hand, we have the DASPER, which is the drifting acoustic spar buoy recorder. This is a little less of a complicated of a device. You can literally chuck them over the side of whatever boat you're on, and then they drift with the currents for several days or weeks, depending on when you can go pick them up. And that's, fingers crossed that you can retrieve them. They do have this satellite buoy, this represented here is the orange circle, to track them at least, so that's helpful. And the main difference between the drifters and the gliders is that they have more of a constant depth of hydrophones at about 150 meters, but both platforms can record a range of frequencies, anything from baleen whales, lower frequencies, to most odontocetes, so toothed whales. So here are some great field photos to see these instruments in action. I don't know, it's hard to find pictures of underwater, or gliders actually underwater, but this is an example when we were ballast testing it in a tank out at the NOAA Science Center. The red circle is where the hydrophone or the underwater microphone is placed on the glider itself. You can take them out on a smaller boat to launch them, and that's just what it looks like when it's sticking its antenna up at the surface to transmit data. And here we have a DASPER in action. We have our very own Alexa Gonzalez expertly lugging, I might add, a DASPER across this NOAA ship SETI. We can see the float here and the satellite buoy there. And then the team is just gently chucking it over the side of the boat as it drifts off to the sunset, awaiting pickup at a later date. Fingers crossed again. Okay, so back to our project goal is really to develop this framework to incorporate these two different platforms cohesively into a species distribution model for Odontocetes specifically. We've identified 3 objectives to kind of guide us through this project. The first being to come up with all the questions we have about how to do this, to kind of identify the things we need to, and the knowns that we don't know, and the unknowns that we do know, that kind of thing. And so the second is to just design and then conduct simulations and experiments based on the things we come up with in the first step. And then the lastly, where we would obviously build this model, this analytical framework, to fit all the pieces together, and we're actually using sperm whales for a case study. And just to remind myself, to let you all know that we are in the early stages of this project, again, we're just coming up with the plan. So there will be no results reported today, but we're really trying to move the needle for PAM data to be incorporated into cetacean stock assessments, so that's kind of where this project, reason we're doing this project. Okay, so the first objective, I'll just go through some of the details about each objective, and some of the questions we are considering include looking at the different platforms and the differences between them, and how we will make them comparable in a modeling, in an analytical framework. And so this diagram is not to scale, but you have just representing how the Jasper's at the surface, while there's variable depth within the glider data that we're going to get, and how both of these platforms can affect the way or our ability to detect animals. And that's also related to the environment that we are surveying. So accounting for that 3D movement is going to be really important, especially with gliders, because we know from previous research, which we're leveraging a lot of knowledge from, that detectability of animals varies by depth. And so we have to really think about what our unit of detection will be. Will it include the number of calls we hear over a period of time, or are we going to develop some sort of acoustic intensity index to quantify presence of animals or even density of animals? So yes, if the analytical questions come up, if we go for, say, an occupancy monitoring or occupancy model framework, we don't really have that traditional survey style of repeat visits where you go to the same place over time and get your presence absence data. So we have to understand our data limitations and what inferences are actually going to be possible. Once we complete this step, we're going to look into running simulation models to kind of answer some of those questions and quantify the effects of the slow movement and the spatiotemporal variability, including information from the acoustic data itself, something about the detectability of the species, and then presence absence data, environmental data, and put it all together with some fancy math to help quantify some of these, some of the variability that we'll be dealing with. And if anybody knows of someone who might be interested in this type of work, we do have funds to hire a temporary research position, so you can chat with me after. Lastly, the step of really putting all the puzzle pieces together, taking what we know from the simulation, what we think we know from the simulation results, and the empirical data that we have already collected from some field experiments that I'll get to in a second, and then choosing what functional form we will be using to build this modeling framework. And using the simulation and empirical data to kind of parameterize the model appropriately. And so that'll be the biggest challenge, I think, of all this. And luckily, we have a great team of collaborators that will be working on it. We do have existing data, which is very exciting to start with. We had some glider missions in spring 2022 and 2023 around the main Hawaiian Islands. We deployed 2 gliders, and they did their rounds from Big Island around Hawaii area and back. And so those were very successful. We just also completed deployments off the West Coast, as you'll see over here. I'm sorry, the tracks, that's all right. The tracks are the different gliders, so 2 separate gliders. And then we had 3 over here on the West Coast between Newport, Oregon and Eureka, California. that were recently retrieved, which was very exciting because, yeah, it was kind of a saga when these things are deployed. And pilots in our program that are constantly having to check in on these gliders. The white squiggly lines represent the drifting tracks from the Jaspers. So there's at least 6 that were deployed. I think there's more. These are just my artist rendition because I didn't actually have them plotted. But also to note that around the main Hawaiian Islands, there are dozens of Jasper drifting data sets that we have from previous surveys. So we have a lot of data to work with so far. Expected data sets include another Cetacean line transect survey that we're going to conduct in 2026, where we'll hopefully have at least 2 gliders along with as many Jaspers as possible, along with data that we hopefully will obtain from the glider rodeo, where Eric Norris, former CIMAR employee Eric Norris, presented a poster about it at a recent glider conference, and it's kind of a come one, come all project. If you have a glider and a PAMP system you want to test out, this is what this is all about. And so hopefully we can use some of the data from that project. And if rodeo brings up chaos in your mind, that's kind of what it's going to be about. So in summary, the PAM strategic initiative is providing us this promising new pathway to progress PAM research. This project is really relying on leveraging that existing research from using a lot of the gliders, or gliders have been used before, so we're trying to build upon it, not necessarily reinvent the wheel, but really tweak the wheel to fit this slow-moving, this data from the slow-moving platforms. And then the pros outweigh the cons tremendously with the challenges that we will face, because we can really improve if this works, we can increase the amount of data we get for cetacean species, which is incredibly challenging and expensive to collect using just large research vessels. And so again, if we know anybody who might be interested in helping us with that simulation portion, please reach out.